Good morning, Amma. In today's class, we are going to discuss about resolution of vectors, resolution of vector, and multiplication of vector. So, yesterday, what we discussed about resultant and a few applications on the resultant. Thereafter, we moved to resolution of vector. In 2 days before, I told that every vector will be resolved into its components. Every vector will resolve into its components. That's what I am going to explain with the help of trigonometry. So this is a block. This is a block. When you are applying force on this, that will act here so that you can pull this object along the direction of applied force. Along the direction of applied force. When you are pulling this will move now. Look, this is the horizontal axis. We are calling this as the x-axis, and this is the vertical axis. We are calling this as the y-axis. Since it is a force, it has a direction. That means it is directed at an angle theta with x-axis. It is directed at an angle theta with the x-axis. Okay. Then why I plot a dotted line here means you can shift this. Already I told these types. When you shift here, its magnitude doesn't change and direction also doesn't change. So no problem with that. But you got a right angled triangle. Look, that picture is zoomed over here. And this is the theta, angle made by the vector. Angle made by the vector with the x-axis. So here you got a right angle. So once you got a right angle, the trigonometric functions will come into apply. First, sine theta and cos theta and tan theta. These three are the trigonometric functions. How these sides, this is the adjacent side for theta and this is opposite side for theta, and they are seems to be perpendicular to each other. When they are perpendicular to each other, you will get a hypotenuse and you got a right angle triangle. Now you are able to apply trigonometric functions like the sine theta, cos theta and tan theta. That's what I am going to hit. So it will give you information regarding opposite side to the hypotenuse, that how many times one to another. Opposite side is equal to hypotenuse times of sine theta. So what is opposite side here? It is this one. Cos theta will give you information regarding adjacent side, ratio of adjacent side to the hypotenuse. One number you will get. One number you will get. That information it will give you, right? And tan theta. So this will give you the ratio between opposite side to the adjacent side. So no need to by heart. When it will come into action, then I will explain. Okay. So what is opposite side? Some hypotenuse into sine theta, right? Hypotenuse into sine theta. Let me change that. Opposite side is equals to hypotenuse into sine theta. Similarly, adjacent side is equal to hypotenuse into cos theta. Okay. So now I am not going to write this. Later I will write this one. So we got what is opposite side and what is the adjacent side. So this is opposite side. Can I give the names? O, A, B. AB is opposite side. Now, AB. So how this is going to be changed? Observe. AB is equal to hypotenuse into sin theta. Is equal to means what? Is equals to right hand side is equals to left hand side. What is hypotenuse here? Hypotenuse is nothing but our force, what we applied. So AB is equals to F sin theta, and what is adjacent side here? OA. OA. Instead of writing this one, I am going to write OA. OA is equals to hypotenuse into cos theta. What is hypotenuse? Force. So there is small substitution. Now observe. What is the AB? AB is opposite side to theta. So we will write here, instead of writing AB, we will write here F sin theta. F sin theta. Instead of writing OA, we will write F cos theta. F cos theta. Right? F sin theta and F cos theta. Now, observe this. Whatever the force that you applied, that is resolved along x-axis and along y-axis. Resolved ante vidipovam. So this force on which you are applying, what it will have, what it will do, it will pull the object towards along x-axis. Simultaneously, it will lift the object vertically upwards. For example, I will tie a rope to a box and try to pull it with your hand. That box will come forward and slightly the front portion will rise down one side. So whatever the force that you are applying is utilized to pull the object as well as to lift the object. To pull the object as well as to lift the object. That's what I will do here. So here, what are the resolving components or perpendicular components of this force? So one is a horizontal component which is represented with Fx, and one is a vertical component which is represented with the Fy. I mean force along x-axis, that is taken as F cos theta. That is taken as F cos theta. And force along y-axis, Fy, is taken as F sin theta. So these are the two resolving components of a given force. So draw this picture. Same thing you can repeat for momentum. Momentum. Because momentum is a vector. Momentum represented with letter P. And another one mg. mg. It is also a vector physical quantity. Now today I will explain this one, how the mg will resolve. Just to go through this one. You all go through this one like this. But mg is a different one. Draw this picture. Pause the video and draw this. Students, so weight is a vector physical quantity. W is equal to mg. How it is resolved into components? In today's class, you will get idea on this one. So here it is a floor and here it is a block. When this block is placed over the floor, normal from the floor will act vertically upwards. Opposite to that, the weight will be act. So this will be on rest. There is no resolving force, no resolving of weight, nothing. Because you don't have any direction here, it is acting towards ground, vertically downwards. Okay. Later, after calculating the resolving components, if you substitute the value of theta, then you will get. Okay, now to calculate or to get the idea regarding resolving components of weight, I will draw another picture. Consider a inclined plane. In this case the weight does not resolve, but here the weight will resolve. Consider a inclined plane, ఏటవాలు, inclined at an angle theta with the horizontal, inclined at an angle theta with the horizontal. Okay, look, now place a weight, this is the weight, I mean a massive object, and weight is equals to mass times of gravity that will act towards the ground. This is mg. And normal of this plane is acting perpendicular to this surface. Here it is perpendicular, and we are calling this as a normal. You can extend this normal downwards, same normal, right? This is a normal. Now, what is the angle made by this weight with the normal? Is theta only. How much it is inclined, that much angle here it will make. The angle made by the weight with the normal is equal to angle of inclination always. Okay, now observe this. These two are perpendicular to one another, and this is a horizontal to this plane, and here similarly you can take another horizontal, so that you will get a right angle triangle here, Observe this one, same one I drawn here, and this is a adjacent side for theta, and this is opposite side for theta, and this is the hypotenuse for this right angle triangle. Okay, can I draw once again by zooming it? This is the inclined surface. So this is a block, the same block I am drawing here, and this is your normal. Here it is your weight. Normal is extended like this, and this is a horizontal line to the inclined surface, and here is the angle made by this one. The same line I am drawing here. To get right angle triangle, just to shift it. If I got a right angle triangle, then I can resolve. That's why I am drawing this one. You can draw on camera. Now, since it is a weight, this is mg. For this right angle triangle, here it is the adjacent side. What is the force which is acting along the adjacent side? Already we got idea. What is that? Ef cos theta. And what is the resolving force which is acting along the inclined surface? Is F sin theta. That is what we got. But here in this case, our force is nothing but mg. How it is? Let me tell you. Force F is equals to ma. Here F is equals to mass times of acceleration. And suppose this acceleration is acceleration due to gravity, then it is called weight. So weight is nothing but a force which is acted towards the ground due to acceleration due to gravity. Okay. So weight is a force which is acting towards the ground due to acceleration due to gravity. That is W is equals to mg. So instead of writing F, I will write mg sin theta, and here it is mg cos theta. ఇది కనపడకపోవచ్చు, నేను చెప్తున్నాను కదా, సో మీరు ఇది రాయాలి. This is mg sin theta and this is mg cos theta. So in space we are not going to write this one. The same physical quantity I am going to show you on here, mg sin theta. So here mg is a wave which is resolved into perpendicular components. One is mg cos theta, which is opposite to the normal. One is mg sin theta, acting towards the ground. Suppose it is at rest due to friction, and this frictional force will be equals to mg sin theta. Okay. Later in classes we will discuss this one. So this is how weight will resolve. Weight will resolve. The angle made by the normal with weight is equals to theta, but here nothing is there. No theta is there. Normal or weight doesn't make any angle with normal. That is one. So normal n is equals to what? Actually n is equals to mg cos theta, right? Mg cos theta. Why the weight does not resolve here? Because of this one. N is equals to mg cos. What is the angle made by normal with mg? 0. 0 angle. Cos 0 is equal to 1. Then what is equal? N is equal to mg. That's why you got here. There is no resolving component here because normal weight doesn't make any angle with the normal. You got resolution here because weight makes an angle theta with the normal. That's why you got resolution. Okay. Note it down. Now the class is over, 10 to 15 minutes only. Multiplication of vector, tomorrow we will discuss this topic. Today it took already a long time to complete this. So tomorrow we will discuss the rest of application. One more application is there and multiplication of vector. Bye.